78 millimeters of hardened steel cast into a nose that came to a narrow point. That's it. That single dimension, the width of 3 fingers pressed together, is the reason Japanese soldiers walked out of fortified positions they had held for months, put their hands up, and surrendered. Not to an infantry assault, not to aerial bombardment, to the sound of an engine coming down a jungle track. That engine belonged to the Matilda, an infantry tank Mark II, built in Britain, considered past its use-by date by the time it reached the Pacific, and yet somehow the only tank that fought on every single day of the Second World War, from the first shot to the last. To understand why that nose plate was so decisive, why it left the Japanese with no answer except to name this machine their Queen of the Jungle, you need to start with a problem that had been killing soldiers since the battlefields of the First World War. The problem was this: infantry kept dying in the open. Every frontal assault stalled in the same way. Machine guns in covered positions. Artillery that could not be silenced quickly enough. Men walking forward into fire with nothing in front of them. In 1934, Major General Percy Hobart, the inspector of the Royal Tank Corps, wrote down a specification for a solution. Not fast, not wide-ranging, a machine that moved at the pace of a walking man, absorbed everything the enemy could throw at it, and kept going forward. His requirement for the armor was specific. Not resistant. Proof. The first attempt, the A-11, did not meet it. 1 machine gun, 2 crew, no cannon. At Arras in France in May 1940, German anti-tank guns found the gaps and went through. The second attempt was different. The Vulcan foundry in Warrington cast the A-12 like a vault. 78 millimeters at the nose, 65 to 70 along the sides, 20 millimeters at its thinnest, twice as thick as any other British tank of the period. The German Panzer IV at that time carried 30 millimeters at the front. The French B-1, the most armored tank on the continent, had 60. The Matilda had more than both. The nose itself was the hardest part to build. It came out of the mold thicker than the specification in certain areas. To avoid adding unnecessary weight, Vulcan's workers ground the excess down by hand. Skilled metalworkers, hours per hull. No automated process, just eyes, hands, and a tolerance they had to hit every single time. In peak production year 1942, they managed 1,330 hulls. In total, across the entire run, 2,987. Hobart never knew what that nose would eventually be asked to stop. In the Western Desert, the Matilda earned its first nickname. An Italian commander at the coastal fortress of Bardia on the 3rd of January 1941 watched his guns fire 46 direct hits on a single Matilda hull. The tank drove back on its own power. His garrison surrendered the same day. British crews started calling their machine the Queen of the Desert. They were right about what the name meant. They were wrong to think it would last. Rommel arrived with 88mm anti-aircraft guns laid flat on the sand, and the desert chapter closed. By mid-1942, the Matilda was being phased out of European service. Cheaper to build, faster to deliver. The Valentine was doing the same job well enough. Most of the remaining Matildas looked like they'd spend the rest of the war sitting in depots. Then Japan swept through Malaya, took Singapore, and by February 1942, Japanese aircraft could reach the Australian coast. Australia needed tanks, whatever could be found. Over the next 2 years, 409 Matilda IIs arrived at Australian ports, along with 33 close support variants from New Zealand. Half the first shipment was stripped for parts to keep the other half running. The Australians took those tired, patched-together machines and started modifying them. Not in a factory, not according to a centralized engineering program. In the field, regiment by regiment, based on what was killing men that week. The first problem the crews ran into was not the armor. It was communication. Buttoned up inside a hull with twin diesel engines running. The same AEC engines that powered London double-decker buses, two of them side by side in the rear, putting out less than 200 horsepower combined. A commander could hear almost nothing outside. The radio inside the tank was incompatible with the wireless sets Australian infantry carried. A soldier 5 meters away, trying to point out a bunker hidden behind 3 meters of undergrowth, had no way of reaching the man inside. One of the blokes from B Squadron described it later as shouting at a tin shed. You could bang on the hull, you could wave your arm, and the tank would just keep moving. Keep its gun pointed at the last thing the commander had seen through the periscope. The bunker you needed hit was 6 meters to the left, and the tank had no idea. The fix was a telephone handset bolted to the outside rear hull, a microphone and headset wired through the armor. Now an infantry section commander could pick it up and talk directly to the tank commander, describe the firing slit, confirm the range. The 3-inch howitzer on the close support variant would traverse and fire. It sounds simple. On a jungle track in a tropical downpour, in the dark, with Japanese soldiers in the tree line trying to crawl close enough to attach a magnetic demolition charge to the hull, it was anything but. That was the next problem. The Matilda's armor stopped bullets, shells, and anti-tank rounds. It did not stop someone pressing a shaped charge directly against it from the outside. The Australians fitted metal panels over the engine louvers and hull sides to make it harder to reach the vulnerable surfaces. Wire mesh went over the engine covers. An armored shield was bolted over the turret ring. Each modification answered one specific threat and revealed the next one hiding behind it. Then the mud. The Matilda's suspension, called, with some irony, the Japanese-type suspension because it had first appeared on a Vickers tank sold to Japan in 1928, was designed for European conditions. The coral mud of Bougainville packed into the sprocket teeth and set like concrete. Crews fabricated scraper brackets on the spot, welding angled metal directly onto the sprocket housings so the mud cleared on the move. The jungle undergrowth tangled in the running gear. Metal guards went over the tracks. Every solution created maintenance. Every modification added weight. By the time a Matilda reached a forward position in New Guinea in 1944, it had been rebuilt, patched, welded, and wired in ways no drawing at Vulcan Foundry had ever accounted for. What it had not lost, what none of this touched, was that cast nose. Still 78 millimeters, still pointed, still stopping everything the Japanese could bring to bear on it from the front. The first major test came in November 1943 at Saddleburg,